Hello, ladies and gentlemen. We're going to have a little lesson on exponent properties. So mine has some extra blue stuff on it. Yours isn't there quite yet, but you should add it to your notes. So really at the end of this lesson, you should be able to see an expression like this and kind of simplify it down so it's not as complicated. So it's kind of the end goal there. Let's review what your function, your exponent properties are that you learned once upon a time, might have forgotten, but we're going to try and remember it right now. So let's start with the first one. And this is kind of the basis of everything else, is if you have two things with the same bases, and when I say base, that's this number here, and you're timesing them together, you need to take their exponents and add them together. So if you have 2 to the second power, you times it by 2 to the third power, you need to do 2 plus 3 in the exponent there to get the exponent over here, which is 5. And if you're wondering where that comes from, well, it comes from the fact if we expand this out, you have 2 squared, which is 2 times 2, and then 2 to the third, which is 2 times 2 times 2, and you times it all together, you have 5 2's times in together, and you get 2 to the fifth power. And let's move on to our next property is the power of a power property, which is you have some base here and it has an exponent. But then there's some parentheses and another exponent on top of that. Well, if you have an exponent to another exponent, you need to times those exponents together. And if you're wondering where that comes from, well, that comes from the fact that if you have an exponent already and then you put another exponent on it, it's doing an exponent of this thing which is now considered the base, and so you have 4 2 to the thirds times in together, so 2 to the third, 2 to the third, 2 to the third, 2 to the third. And remember, if things have the same base and you're times them together, you add the exponents. So we're going to add these 4 exponents together, which is 3 plus 3 plus 3 plus 3, and that gives you 12. So if there's 4 of them and you have to add them all together, it's 4 times 3. So that's where that property comes from. You got power of a power. Over here, we got some other properties. You do not need to worry about this one at all. It's just if they have the same exponent, you can multiply bases. Whatever. Doesn't matter. Don't need it. But what you do need is this thing here is quotient of powers property. Once again, I do not like this symbol. It's a terrible symbol. Instead, we're just going to write it as a fraction. So if you have two numbers with exponents that have the same base, if you're going to simplify that, you can just subtract their powers. And so let's say we have 5 to the 6 over 5 squared. You're just going to write out 5 to the 6 minus 2 power, which gives you 5 to the fourth. And if you're wondering how it works out like that, here I kind of expand it out. 5 to the 6th power is 6 5's times in together, and 5 squared is 2 5's times in together. When you have this, you can actually cancel out a 5 on top and bottom. They divide out. It divides it out. And it leaves you with 4 5's left on top, which is 5 to the 4th power. So there's your quotient properties in action. Okay. So we have lots of different properties. We got 2 more we're looking at. We got this one, which is the 0 exponent property. Anything to the 0 power is 1. So, I wrote just a ridiculous number here. 15,674,218 to the 0 power is 1. Or I could have made it negative. If you have a negative number to the 0 power, it's also 1. Just anything to the 0 is 1. You just have to make sure it's only the thing that has the exponent is 1. Say I have 3x0. This is not 1. It's just 3 times 1 because only x had the exponent of 0 on it. So be aware of that. Next property is negative exponent property. So with this one, if you have a base and it has a negative exponent, you can put that under 1 and change the exponent to be positive. So let's say I have 6 to the negative third. I can put that under 1 and it becomes 1 over 6 to the third power. And this is not on your notes, but the kind of the opposite is true. If it's already on bottom of the fraction and it has a negative exponent, you can put it on top and turn the exponent to be positive. And that's going to come into play with what we're doing down below. So there you go. A whole bunch of different properties We got if they have the same base and you're just multiplying, you add the exponents. If you have a power to a power, you have to multiply them. If you're dividing them, you have to subtract exponents. And if anything is 0 is 1. And then if you have a negative exponent, it goes on bottom, or if it's already on bottom, it goes on top of the fraction. So we're going to use all these properties to kind of simplify things down. Looks like you got 12 problems down here at the bottom you need to practice with. I'm going to work on 2, 8, and 11 so you can see it in action. And kind of remember some other things about multiplying expressions. So the way this works is if you're multiplying two of these factors together, these numbers are just constants. They are going to times together. So I can put 5 times 2 in front. And then we got x to the third and x to the fourth. So I'm going to put x to the third times x to the fourth. And this is all multiplying together. So these two can multiply together. You get 10. And then we got this part. We got x to the third times x to the fourth. Remember, if they have the same bases, you're going to add the exponents. So we're just going to do 3 plus 4 on top, and we get 7, and that is it. It's all simplified down. Okay. If you haven't read the directions, you should probably do that. We don't want to leave any negative exponents, which is going to come into play on number 8 and 11, and you're going to see soon. So I have this. I need to simplify this fraction. Well, these can simplify. 8 divided by 2 is just 4. I'm going to put that on top. And then I got this n to the negative second on top and n to the positive second on bottom. Well, if I have two things with the same base, I can subtract their exponents. So I get negative 2 minus 2. And when you do that, that actually gets rid of it on bottom. So actually, there's nothing down here. It's just a 1. We dealt with the 2. We dealt with the n squared. We're doing a subtracting there. And so it's just going to be 1 on bottom. And now we got 4 to the 4 times n to the, well, we need to subtract these. That's going to give me negative 4. Well, we are not supposed to end our problem with a negative exponent. And so, actually, I need to take this thing and put it down on bottom to make it be a positive exponent. So I'm going to have 4 over n to the 4th power. And now I'm done. It is all simplified. So there you go. So remember, if you have a negative exponent at the end, you can just throw it on bottom and change it to a positive exponent. Okay, so there's 8. And now we're going to go to one that's kind of a doozy. We're going to jump to 11. It has a lot of exponents, a lot of powers and stuff. It even has zeros in it. So let's work through this. And kind of the way I like to work through it is I work inside out. So find the inside most parentheses and see if we can simplify it. So this has parentheses here, and there's nothing going on inside, but I want to get rid of those parentheses, and the way you're going to do that is deal with the exponent to the exponent part. So I'm going to have my big outside ones, and I got a negative 2 outside, I got x to the 0 times 3x to the 0, and then down underneath I have exponent to exponent, which means I need to times them together. So I'm going to have x to the negative 16 power, because negative 4 times 4 is negative 16. All right, so now I got this. Sweet. So now I want to work, again, inside out. So I'm going to simplify the inside part before I deal with this negative 2. Well, this 3 doesn't have anything to interact with. So I'm just going to put it out front. And then I see I have an x to the 0 and x to the 0. Well, anything to the 0 power is just 1. So really, up top here, I just have 3 times 1 times 1. And then on bottom, I got x to the negative 16th power. Well, 3 times 1 times 1 is just 3. And so I'm just going to get rid of those because I can. 3 times 1 times 1 is just 3. So I'm going to leave that there. Just kind of put a 3 out front. If you wrote it out, that's fine. It's fine. You can put that. Just realize it's just 3. But now I'm here. And once again, I have something inside and a power. It's got an exponent. So actually, I need to do these exponents inside times by the exponent on the outside. So this 3 does not have an exponent on it. But if that's the case, just remember the exponent's always 1 if there's nothing there. And now I'm going to take these and times them together, and I need to take these and times together. So 1 times negative 2. And then I got negative 16 times negative 2. And that's going to be 3 to the negative second power. And then down underneath, I got x to the positive 32nd power. All right, we're looking pretty good here. We are almost done. Not quite, though, because this has a negative exponent. So at the end, if you have a negative exponent, you just need to put it in the other part of the fraction and change it to be a positive. So the top is losing this 3 to the negative second. And it has nothing up there, so we're going to put a 1. Remember, if there's nothing there, you can always put a 1. And now we got 3 to the positive second power, x to the 32nd power, and I'm almost done. Not quite, because you can do 3 to the second power, so we're going to do that. 3 to the second power is 9. And now we got x to the 32nd. And now it's done. Finally, we got to the end. Took a few steps, but that's okay. Sometimes you can write out multiple steps, and that's fine. It helps you kind of think through it, write out multiple steps, instead of trying to do it all at once. So there you go. That's how you get started on your exponent properties. With these other ones, just practice your exponent properties, see if you can get them simplified, no negative exponents at the end, and good luck.